Okay, this is your tutorial for significant figures and using the rules. So I went ahead and wrote the rules here so we can go ahead and refer over to them, and then I have several examples. What you have is on the first one, 6.005, we know according to rule 1 that anything that's a non-zero is significant, so therefore the 6 and the 5 are significant. And then we look at these two zeros. Well, according to rule 2, it says zeros that are in between non-zero digits are significant, so it's a sandwich rule that I spoke about, so that those two are significant, making it a total of 4 significant figures. Okay, for the next example, if we look at the first two zeros and we look at rule number 3, it says zeros to the left of the first non-zero digit. So this is the first non-zero digit, these zeros are to the left, and it says that they are not significant. So therefore we don't count them. The 3, we would count it. The 5 and the 2 would be counted as well. Okay, and that's because of rule number 1, that all non-zero digits are significant. Okay, as far as this zero is concerned, it says in rule 2 that zeros in between non-zero values are significant. So it's a sandwich rule again. The 3 and the 5 are like the pieces of bread, and the 0 is sandwiched in. That would make this a total of 4 significant figures as well. Okay, for the third example, this one is based on the first number for all non-zero digits, so that's significant. But if you notice that for rule 5, if these zeros would have had a decimal point, then they would have been significant. But because there's not a decimal point, they are not considered to be significant, so therefore one significant digit. On the other hand, if you have the same number but you put a decimal point, it makes those zeros significant because it makes it a definite amount. So in this case, that would be 4 significant digits. Okay, on my fifth example, remember we said that according to rule number 3, it says zeros to the left of the first non-zero digit are not. So this is the first non-zero digit, this is to the left, that is not. This is significant because it's a non-zero, so again, that's according to rule 1. This is significant because it's sandwiched in between, and that's according to rule number 2, zeros in between non-zero digits. And these guys right here at the end are significant, and this is according to rule number 4, because it says for numbers with decimal points, which it does have a decimal point, zeros to the right of non-zero digits. Okay, well, these zeros happen to be to the right of a non-zero digit. They happen to be, it says they are significant, so they happen to be significant. Okay, so therefore all of these numbers are significant after the decimal point, not including the 0. So it's 1, 2, 3, 4, 5. 5 significant digits. Okay, for the sixth example, okay, the 2 and the 4 are significant because of the non-zero rule, rule number 1. This one is not significant because there is no decimal point in this number. There is no decimal point at the end of the number, and so therefore that makes it only 2 significant digits. Okay, now if we add that decimal point according to rule number 5, we find out that these numbers, all 3, will be significant. And again, the 2 and the 4 are according to rule 1, all non-zeros. For number 8, or example 8, again, this is our first significant, or our first non-zero digit. It says any zeros to the left of that, and that is according to rule number 3, zeros to the left of the first non-zero digit. Those are not significant. And then the 4, the 6, and the 7 will be, because they're non-zeros. This 0 will be significant according to rule number 4. For numbers with decimal points, zeros to the right of non-zero digits are significant. So here's some non-zero digits. This one's to the right. It has a decimal point, so therefore significant, making it a total of 4 significant figures. Okay, this one, again, the rule that states that any number where you see the first non-zero and there's zeros to the left, those zeros are not considered to be significant. And that is from Rule number 3, zeros to the left of the first non-zero digit are not significant. And then this one is significant because it's a non-zero number, so making it 1. Okay, last example. So we have 9,305. The 9, the 3, and the 5 are significant because they're non-zeros, and the 0 is between the 3 and the 5 sandwiched in, so that makes it significant. So that makes it 4 significant digits. Okay, so now we're going to look at multiplication and division and addressing significant figures in this situation. So when we multiply and divide, we're always going to take the least amount of significant figures and apply that to the answer. So if we look at the two numbers that we're multiplying in the first example, 42.62, that one has 4 significant digits, and it's multiplied by 3, which has 1. So 1 is the least amount. When we do this in the calculator, we get 127.86. So according to the rule, it states that we will need to have only one significant digit, which is the least. So in this case, this would have 5 significant digits. It's too many. So how can we make it as closely as possible to the correct amount and still have one significant digit? Okay, if we make this and round this to 100, our 100 is the closest amount, and that would give us one significant figure. If we look at the next example, we're multiplying 840 and 2.7. Both of those numbers have 2 significant figures, so that means that our answer has to have 2 significant figures. On the calculator, we get 2,268, so we have to round it off to 2. We start from left to right. So we start with the 2, that would be 2,000, and then we're going to keep that 2. While the 6 rounds that 2 to a 3. So if we use 2,300 as our answer, that would still give us 2 significant digits, and it would be as closely as possible to the original amount. Okay, so we look at our third example, which is division. Exact same rule that applies to it. 381.6 divided by 5.30. We notice that this has 4 significant digits, this one has 3, so therefore our answer has to have 3 significant figures, which is the least amount. Now when we do that, our calculator gives us a number that has 2 significant digits. So to address that, because it has less than what we need, we're going to go ahead and put a decimal point, which just tells us it's an exact amount. We can put a 0 to make it significant, and that would give us 3 significant figures, and it's still the same value as the one in the calculator. Okay, on the fourth example, we're dividing 71.7 by 3. 71.7 has 3 significant figures, 3 has 1. So therefore our least amount is 1. Our answer comes out to 23.9. So therefore we need to reduce it to one significant digit. So what's the closest to 23.9? Even if we rounded this to 24, it's still not close enough to 30. So it's closer to 20, and using 20 would give us one significant figure. Okay, for addition and subtraction. I tend to think that this one's easier. All you have to do is look at the place values, and the one with the least place values, that's the place value you want your answer to have. So if I add these two numbers, 546.2 only has a tenths place value, and 3.865 has tenths, hundredths, thousandths. So the least amount would be the tenths. Therefore, this is my answer that comes out. I need to get rid of these. The 6 will round the 0 to 1, so my answer is 550.1. So it'll also have one place value just like the one with the least. Okay, if we look at 2, we're adding these two numbers. 38 is a whole number, has no place value, and then 0.12 is 2 place values, or 6,000.12. And so when we add these, this is our answer. We want to keep it to a whole number, so therefore we're going to get rid of the 0.12. And if we put 6,038, it's a whole number, has no place value, so it would be just like the least, and that would be our answer. Okay, in our third example, they both have one place value. So when we add them up, or subtract them, we're going to go ahead and get one place value as well. So we keep the answer as is, no change. And then for the fourth example with subtraction, we subtract these two numbers. The first one has 3 place values after the decimal. The second one has 1. So when we get an answer, we get 3 place values. So therefore, we're going to keep it to 1 place value, which is the least of the 2 that were subtracted, and we're going to get an answer of 0.5. Okay, and that's how you do significant figures as far as determining them, multiplication, division, and addition and subtraction.